Now for counting purposes, if I gave you this slope and you had to graph, or you had the equation, this is your slope, then you have to put that negative either on top or on bottom. Okay? You don't want to count two negatives. Okay? You'd want to count down 1, 6 to the right, or 1 up, 6 to the left. Okay? So if you just to tell me the slope or put it in an equation, put that negative in front. For counting purposes, when you're going to count it off, put the negative on top or on bottom. It doesn't matter which one. Does that make sense? Okay. So let's look at these. Knowing this information, you know the slope, you can see the line. Do you have enough information to write the equation of this line?
You can do the m slope and then find one of the y coordinates.
Right. You can find any if you have another point, you can use a point and a slope to find an equation. We're going to do that more on Thursday, but that requires a little formula. Unless you know one very special point, which allows you to just pop it right into the form. Do you have that one special point you need in this case?
Yes.
Yeah, the y-intercept. Yeah, because remember our slope-intercept form is y equals mx plus b, and b is specifically your y-intercept. Yeah. You have to plug in y equals 0 and solve for the x-intercept if you want that one. But slope-intercept form gives you m and b. M is your slope, boom, negative 5/3. And b is your y-intercept. Where does it cross the y-axis? Yeah. And that's a marked point. If it's not a marked point, it might be going between numbers and you can't use that. But if that's a point you're given here. So the equation of this line is
Y equals 5 over 3x.
plus 1. Yeah. Okay. So write the equation of this line, but put it in slope-intercept. I'm sorry, put it in function notation.
You said you wanted fraction, or you want actual. You want fractions or decimals?
Yeah, use fractions. Yeah, yeah. Unless you're working like a real world problem where a decimal makes sense, stick with fractions, lowest term fractions. And then, yes, minus 2. Okay. Because we have that specific point, it was a marked point on the y-axis, we can use negative 2 for our b. And we're given the slope. That's all we need. We just plug in the slope and the y-intercept. And there's your equation. Okay. So on this one, right here, this corner, find the slope and then write the equation. Go ahead and write it both forms, just to see how they're the same.
On the left?
Yes, this one right here. Mm-hmm. So what's your slope? Over 2. Always put that in lowest terms. Yeah. So for counting purposes, you could leave it as 4 over 1 because you need a ratio. Okay? 4 over 1 would mean I go up 4 over 1. Hey, yeah, that's a point on the line also. Well, because these are the 2 points you were given that ended up 8 over 2, well, that's fine. Just put it in lowest terms. Okay? Now, if you had counted the other way, you could have counted 8 down, negative 8, and then 2 to the left, negative 2, and you would have gotten m equals negative 8 over negative 2. Is that still the same? Yeah. 2 negatives are still a positive. That's positive 4 over 1, or, for terms of putting it in your equation, just 4. Okay? So two negatives make a positive. So you're either, if you go down and left, that's the same thing as going up and to the right, two positives, two negatives, positive slope. Hey, I was expecting that. I was expecting a positive slope because it's an upward line. Am I expecting a slope greater than 1 or less than 1? Yeah, an absolute value of my slope should be greater than 1 because that's a pretty steep line. Yeah, and 4, that's really getting steep. And my equation? Right. It goes through, yes, the origin. And that means my b is, so little b, in this form, little b is your y-intercept and is your constant. In the other form, ax plus by equals c, big C is your constant. So your basic forms of a linear equation have an x value, an x term, a y term, and a constant term. Okay? Having an x term and a y term is what makes it a diagonal line. This is a diagonal line. It's got an x and a y. But if it doesn't have a constant, then it goes through the origin. If it does have a constant, either a plus b or in the other form equal big C, if it has a constant, then it doesn't go through the origin. If it has an x and a y, it's diagonal, but whether you have a C or not tells you whether it goes through the origin or somewhere else. Okay? When it's in this form, that b is the actual place it crosses, which is the origin there. And that can be written as that or as f of x equals 4x. And don't be fooled, when it's in function notation, yes, there is still an x and a y. It's just that f of x is y. Okay? But there's no constant, it goes through the origin. Now as far as this one, hold on to this, because this one does not have a specific, you can see we're not really sure where it goes through the y-axis. We're not sure what its b is. Okay? So if there's not a marked point on there, you can't see, but we're going to look on Thursday, we're going to look at writing equations if we don't have the y-intercept. We have a slope in some other point. Okay? So the easiest way to write an equation, given a graph or just the information, slope and y-intercept, boom, y equals mx plus b. You're done. But you have to use a special formula if you don't have that b. Okay? So we'll put this aside for now. We'll come back to that last one to start off on Thursday. Okay. So to find slope, you can find it from a graph. Another way to find slope is given given 2 points. A line is defined by 2 points. There are infinite points on a line, but if you have 2 points, connect the dots, you have a line. Okay? So if I say there's a line that goes through these 2 points, you know exactly what that line is. Okay? And just with that amount of information, you can tell me the slope, and then as we'll do on Thursday, you can also tell me the equation of the line. Because you've already got that line defined with 2 points. So the first thing you'll want to do is find the slope of that line. And the slope of a line, if you are given 2 points, is change in y over change in x. Remember, change, delta, delta y, delta x. Delta means change, and change means the difference between 2 things, how things change. So that leads us to the formula you're used to seeing, I'm sure, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you're given 2 points, and you're given points x1, y1, and x2, y2. Now, it makes no difference which is point 1 and which is point 2. Doesn't matter. We just have to use those to distinguish, yes, there are 2 points. The other thing the formula is telling us, besides the fact that there's 2 points, is it's telling don't twist them. It makes no difference which is point 1 and which is point 2. Just make sure that when you do the subtraction, you do it in the same order on top as you do on the bottom. That's all that matters. What we just did here, remember, it didn't matter if we counted down and to the right or if we counted up and to the left. It doesn't matter whether this is point 1 and this is point 2 or vice versa. It's the same slope everywhere. Okay? And that's the same if you're not given a graph, but you're given 2 points. It doesn't matter which is 1 and which is 2. So to be consistent, this is my strategy because otherwise I'll make careless mistakes with negative numbers, is I just consistently, just like I'm reading, move left to right. Okay? So if you say, for example, you've got the points negative 3, negative 7, and 12, negative 8. The important thing to remember is that subtraction is in the formula. So you are subtracting these two values. Whether the values are positive or negative themselves, you are subtracting them. And just make sure you don't twist them. So to avoid twisting, on my case, I go just left to right like I'm reading. So I go, my y values are -7 and -8. So my slope is -7 minus -8. Both of my coordinates, my y coordinates are negative, and so I'm doing a negative minus a negative. Okay. And my x coordinates then are -3 and 12. And again, I'm just going left to right. -3 minus +12.
Does it matter which one you put as y2?
Nope.
Okay.
Nope, that's what you're talking about. It doesn't matter. Yeah. The slope is the same in between any 2 points, and it's the same whether you move left to right or right to left. The point is, don't twist it. It's okay if I did -8 minus -7 on top and then 12 minus -3 on bottom. That's fine too. But I would not go -7 minus -8 on top and then 12 minus -3 on the bottom. I don't twist them. I don't twist the order of them. Okay. Just make sure you remember that subtraction, and then the more you're comfortable doing these integers in your head, the better. Okay? But back it up in the calculator. Practice doing it by hand, and then check your work in the calculator so you have both the integer skills and the calculator skills. Don't lean on this as a crutch. Use it as a tool to increase your mental math skills and check your work. Okay? But do not miss this problem because of the computation. Okay? So -7 minus -8 is -7 plus +8, so that's 1. And -3 minus 12 is -3 plus -12, -15. Okay. So my slope is -1/15. When I write the answer, I just pull the negative. If one of them is negative, I just pull the negative out front because the whole slope is negative. Okay. Let's see what happens in these. Set these up and evaluate them as quickly as possible, because we want to compare some differences here. So, 2, 5, 3, -4, 3. Those other 3 real quick. Let's see what happens. You end up with a negative on top and a negative on the bottom. That makes the whole thing positive.
Say on that one, what in it, since the y is the same.
Exactly. Yeah. And you can see that initially. If you catch that initially, you know that's what's going to happen. Once you push it through the math, it doesn't matter what the denominator is. What's my answer?
0.
Right. Yeah. Doesn't matter if the denominator is positive, negative. Doesn't matter. The numerator is 0. The value is 0. So what does that mean? Is that equal to 0 also? What is it equal to? Yeah. Yeah. That's what's called undefined. Undefined means it doesn't exist. It means you cannot divide by 0. The universe will implode. Don't do it. No. Dividing by 0, can't do it. A lot of people will, why not? What's the difference between those? Okay. I'm going to slide up and show that real quick. Sometimes this little thing helps remember the difference between that. Let's say you had a pizza, and it's an 8-slice pizza, and you ate 3 slices of it. So what fraction of the pizza did you eat? Right. 3 slices you ate, but the pizza was defined by being cut into 8 slices. So that's the whole. Okay? All right. There's a 4-slice pizza, and you ate 1 of them. The fraction of the pizza you ate? 4. No problem. A whole pizza is 4, the denominator, and you ate 1 slice of it. Okay. Well, let's say the pizza came in 2 slices. You were really hungry that day, so you ate 1. What's the fraction? 1/2. Okay. Well, one day he delivered it to you and forgot to cut it. Okay. So what is the denominator of that pizza? 1, not 0? Yeah, there's 1 big slice, exactly. Exactly 1, yeah. How much did you eat? You weren't hungry that day. Yeah, 0. You either eat the whole pizza or none of it if it's not sliced. Yeah. Especially if you're not a good problem solver and just take the knife out. But yeah, so in this case, none. So it's okay. This means 0 over 1 or 0 over any denominator is fine. I just ate 0 pizza. Not a problem. Then there's 1 slice to the pizza, though. Okay? Sure, it wasn't cut, but it's still 1 whole. The denominator is the whole has 1 piece instead of multiple pieces. So what on earth would this mean? Yeah, there was no pizza. Exactly. The pizza that doesn't exist. Now that is different. Not existing is different from being 0. Okay? So this equals 0, and this is what's called undefined. The pizza is undefined, which means it doesn't exist. 0 is not the same thing as not existing. 0 exists. 0 is a real thing. Yeah, I get you hungry. This is a good one right before lunch, right? Okay, so this slope here is nope, undefined. The slope doesn't exist or is not. You could say no slope, but I want you to avoid doing that because that makes your brain sometimes think 0 because we think of no or nothing as 0. It just doesn't even exist. So just say the slope is undefined. Okay. Is the mathematical way to say that, which means it doesn't exist, there is no slope, but we say undefined. 0, however, is a real slope. Now, these are basically 4 cases that could happen. When you have slope, you either count it off, or you have 2 points, or you just know the characteristics of a line. But these are important differences here. Here, we got a slope that was negative. Okay? So this makes what kind of line? Yeah. And it's diagonal as well. Okay? So it is both diagonal, I'll abbreviate that, diagonal, and you could, and the way to think about this too is you can walk on it. It's like walking downhill. Okay? So you walk downhill. Okay? So if you have a negative slope, you know you have a diagonal line and it's a downward line. In this case, it's also steep or shallow? Shallow. Very shallow. Absolute value less than 1. Very shallow line. Okay? Now here, you have a diagonal line or horizontal or vertical?
Diagonal.
Yeah, you still have a diagonal line. Okay. Positive slope, so it's like walking uphill. Okay. So if you have any slope that is a number, a positive or negative number, you have a diagonal line. Just like you look at an equation. If it has an x and a y, having both an x and a y is going to create a diagonal line. And that diagonal line will have a positive or negative slope, depending on whether it's an upward diagonal or a downward diagonal. The equation has an x and a y. The slope is an actual number besides 0. Okay? Now, What kind of line, if you have slope equals 0, obviously I just told you it's not a diagonal line, because diagonal lines have positive or negative slope. So what kind of line is n equals 0? It is straight, specifically horizontal. Yes. So, and another way to think of that and remember that is that you can still walk on it. Okay, this is a horizontal line, and it's like walk on flat ground. Okay. If you can walk on it, it has slope. Negative or positive makes it diagonal, up or down. Flat ground, slope of 0 is flat ground. Horizontal, you can walk on it. Okay. What kind of line is this?
Vertical.
Right. So this is a vertical line, and can you walk on it? Not unless you're Spider-Man. So this is like hitting a brick wall. Huh? So there's not even any slope. If you can't even walk on it, then the slope doesn't exist. Okay? So your vertical line, slope undefined. If you're given 2 points and this is the result you get, oh, vertical line. There's no ambiguity here. There's a lot of different ways diagonal lines can look, steep and shallow and up and down. But if you've got slope equals 0, you've got a horizontal line. If you have a horizontal line, you know it has slope equals 0. Period. No ambiguity. That's the characteristic of the line. Same thing with vertical. You see slope undefined, you know you have a vertical line. If I say here's a vertical line, you say, well, the slope is undefined. There's no wiggle room. Okay? In fact, as we transition from this into looking at horizontal and vertical lines a little closer, let's take a look back at these 2 points. For the horizontal line, what do you notice about these 2 points? Same what?
The y is the same.
Yeah. Okay. They have the same y value. If I gave you some more points, what would you notice about all those points that are on this horizontal line? The y is 3. It doesn't matter what x is. Imagine the xy axis, and on the y-axis you go to 3, and you got a horizontal line. It doesn't matter how far you go to x on the left and the right. It doesn't matter what x is. You're going to go up 3. Okay? What is the name, or rather the equation of this line? Yeah, because that describes it. Y equals 3. You don't need to plug in any x's because x can be anything. It doesn't matter. Y equals 3. So that is the very name, the equation. You just wrote the equation of that line. What about this one? What do you notice about these 2? Yeah. Okay. If I gave you more points on this line, yeah, and you can see any possible y, it doesn't matter. Now imagine that xy graph. Go to x equals -2 and draw that vertical line through it. Doesn't matter what y is, big, small, 0, doesn't matter. What is x? You're always going to move over to -2. Okay. So what is the name of this line? Yeah, that very fact defines, names the line, tells you the equation. You just wrote the equation of that line. Make sense? Okay. So we can find slope of the graph with 2 points, and also finish up now with looking at some equations in general, and then specifically horizontal and vertical ones. We can find them with slope. Okay. With the graph, 2 points, and now with an equation. And the equation depends on, finding the slope depends on what type of equation we have. Okay, so let's look at these equations. So we got y equals -3/4 x. F of x is equal to x minus 6. Do 3x minus 2y equals 9, and 5x plus y equals 0. What kind of lines do these make? Diagonal, horizontal, or vertical? Yeah. These are all diagonal lines. You see there's an x and a y in all of them. Wait. Whoa, what about this one? Yeah. The what, sorry? Yes, exactly. So this isn't, just for graphing purposes, go ahead and rewrite it as y equals x minus 6. Then sometimes it's easier for your eye to see the y. Yo, that's my xy graph, but it means the same thing. There's an xy, there's an xy, there's an xy, there's an xy. These are all diagonal lines. Now they're in different forms. What form is this one in? What should we call? Specifically, slope-intercept form. Because it tells us the slope and the intercept, the y-intercept. We can also find the x-intercept by plugging in y equals 0, as we saw before. What form is this one in? We could write it like that, same as slope-intercept, but instead we wrote it function notation, right? Which gives us the exact same information as slope-intercept form. We just wrote f of x instead of y, but it gives us the same slope and y-intercept. And what form are these in? Right. So standard form, which is ax plus by equals c. Whereas these are in y equals mx plus b, and this is the same thing, but it's just f of x equals mx plus b. It gives you the same information. And so all of x's and y's, you know they're diagonal. And so to find the slope of these diagonal lines, because diagonal lines are the only ones you have to worry about finding the slope for, like doing the math to find the slope, because you know horizontal and vertical lines, you always know what their slope is. So these are the ones that are going to be numbers, either positive or negative numbers. So if in slope-intercept form, what's our slope? Period. No math. Don't get confused with like the standard form where I said, oh, you know, you flip the sign. No, that's for standard form. Okay? Slope-intercept form, boom. There it is, the coefficient of x. No math needed. What's the slope of this one? 1. Yeah. 1. Coefficient of x, positive 1. Okay. So you know this is upward or downward line? So downward, you know, of course, it's diagonal. And is it steep or shallow? Yeah, kind of shallow. Less than 1. Its absolute value is less than 1. Note that the slope is just a number. Never include x in the slope. X is the slope is a number value. This one, upward or downward? We don't know it's diagonal, of course, because it has an x and a y. And steep or shallow? Yeah. Middle of the road, actually, yeah. Yeah, it's just average. 1 is the middle point. Bigger than 1 is steep. Smaller than 1 is shallow. The bigger it gets, the steeper it gets. The smaller it gets, the shallower it gets. But 1 is considered middle of the road, so we'll just say average. Average or middle. Okay. Okay. Now, if you're in standard form, it requires a little. You can solve for y to find the slope, but that's a little more work than you have to do. But do note, remember, when we solve for y at the end of that class last week, then that means what happened to 3x when we pushed it over here? Right. And if we solve for y here, what happens to 5x when we push it over there? So it flips the sign of things. Okay? So don't get, when it's in this form, when it's solved for y, then that is the slope, as is. But when it's in standard form, you can find the slope. You just have to use this formula. M equals negative a over b. Now, as I